I'm here to talk about the importance of grace, which actually has pretty much already been covered, right? But I have a little slight twist on that, as you might have guessed, and why we need more women in HPC. So I'm going to start with a question, which many of you are already answering. What is the percentage of registered grace users that are women? Just give you a moment to talk two competing views. Somebody once told me that this is one of the hardest questions they have to answer as somebody who works on exascale machines and is looking at how you're going to move MPI forward to exascale, how are we going to address MPI and fault tolerance. And they said that this is the hardest thing they've ever had to answer. And I was like, really? Okay, I'm going to stop there. The correct answer is the one that you're going for, 22%. So my question now is this good or bad? So I'm going to be unusual. This is normally I would always have slides. I'm an applications consultant. I love benchmarking graphs. I love rate of distribution functions. But I think this topic merits a slightly different approach. So I'm going to talk at you for 20 minutes, I'm afraid. So what do we know about the proportion of women in the broader HPC community? Believe it or not, that's not a simple question to answer. It's a question I've been tackling since I started Women in HPC 2 years ago. So to start off, we can start looking at HPC centres. So as with Grace, 22%. I'm lucky enough to be part of the team that helps run Archer, the UK National HPC facility. There are 17% of our users are women. Okay, so not quite as high as Grace, but Grace looks about the right ballpark. When we look at our training, we run a national training program out of Archer. We have, I think, 50 days of training per year across the whole of UK, free to UK academics in all UK universities. 21% of our attendees are women on that course. So, 15 to 22% is where we're looking. Looking beyond HP systems to conferences, because at the end of the day, many of you will class yourselves as physicists or chemists or more and more biological sciences and humanities. So those actually look at HPC conferences. I have data from 3 recent conferences in the UK. The Exascale Applications Conference that was held in 2013 and 2015. Here we had 9% in 2013 and 15% in 2015 that were women. And then when you look at something slightly more specialist, the 2013 Partition Global Address Space, PGAS conference. It's very specialist, somewhat niche. Only 5% of the attendees were women. And the majority of those women were from the hosting institution. This shows that conference attendees at least appears to be somewhat lower than what we're seeing on systems. We see this replicated on the international stage. Supercomputing is held in the US every single autumn. It's the largest HPC conference in the world. Last year it had over 12,000 attendees, all descending on Austin. In 2015, 13% of the attendees were women. The breakdown has not been released, but there's a lot of assumption amongst the steering committee that a large proportion of those women were on the exhibit floor, because supercomputing has a huge exhibit floor as well as a technical program and tutorials, which means that probably the proportion of women in the technical program was even lower than 13%. Perhaps these numbers are lower because women are less likely to travel to conferences. That's posited quite a lot. So where else can we look? There's currently no undergraduate degree in HPC. I'm pleased to say there is an HPC MSc at EPCC. If you want to come, that was a lot of acronyms in one sentence. I do apologize. If you want to come along, I can talk to you about that too. I'm very proud of that. Where do people come from in HPC? Well, as I've already mentioned, physicists, chemists, I'm a physicist. So let's look at the UK academic institutions. What proportion should we expect from the main feeding subjects? We've got the statistics from the Higher Education Statistics Agency. So we start at the good end of the spectrum. Biological sciences. 45% of UK academics in biological sciences are women. That's really very good. Earth, marine, and environmental science, 36%. Mathematical sciences, we dropped to 29%. Chemistry, material science, 27%. You see a trend, maybe? Computer science, and we're now getting down to the techie subjects, if I'm allowed to say that in this room. 22% computer scientists are women. Engineering and technology, 19%. Physics and astronomy, 17%. I've picked those topics out as I believe at the moment they are the core users of HPC in the UK. I believe that is changing. I think humanities will be moving in swiftly, and there's a good place for them, and that will change it dramatically, I suspect. But what's interesting there is that even with Grace being better than all the other numbers I've given you today, the proportion of Grace users sitting at 22% is lower, is at the low end of that spectrum. When we look at the proportion of users of Archer that are women, which is 17%, we're right down the bottom. That's how many women there are in physics, which was the lowest of those numbers I read out to you. That suggests to me that even though we've got all of these feeding subjects coming in to HPC, women are not making that transition as often as men. So my final data point to help us establish the percentage of women in the HPC community is to look at scientific publishing. Again, this is a difficult subject to tackle. Thankfully, a 2011 study was taken on ACM-affiliated conference proceedings, ACM being the Association of Computing Machinery. It revealed that between 1967 and 2009, the proportion of female authors on conference papers went up from 7% in 1967 to 23% in 2009, bang on the proportion of Grace users. But as we've just seen, well, I should say, that number includes all ACM conference proceedings. That includes far more than just HPC. Preliminary findings from research done by women in HPC suggest that the proportion is far, far lower for HPC papers. Indeed, it may well be as low as 6% for some of the really niche areas. So with that context, it would appear that 22% of users of Grace being women is actually pretty astoundingly good, and I'm very pleased to be here to talk about that. But I'm not quite so happy when we look at the proportion of women in the UK and Europe being at 51%. Suddenly, sitting below a quarter is somewhat disappointing. It's great, but we've got a long way to go. So what I should have asked first is, well, is it a bad thing? Now, I just answered my own question, and I guess from the title of my talk, you kind of know how I feel about this. I think diversity is a really important goal. But I'm just going to give you a little bit of incentive as to why, just in case we're not on the same page. Did you know, for example, that diversity does improve scientific output? The findings in the literature concerning the effect of gender diversity on team performance suggest benefits of team process, or team IQ, which is when you get a group of people together and you measure their team performance. It is improved when you have a diverse team. We actually find that the worst team is when you have a one man or woman in an all other gender team. That's the worst thing you can do. You're much better having all men or all women. A diverse team, you will have more scientific output, you'll have more innovation. You have to work together, which is sometimes challenging. Apparently, according to managers, managing a diverse team is a more challenging role. Business is also recognizing the positive steps that come from increasing the proportion of women. Includes increased turnover. Countries' GDP goes up when they have more women on business boards. Businesses are realizing that by improving diversity, they actually reach a new consumer market. For those of you who are applying for Horizon 2020 funding, you'll realize there's now a gender dimension in there. That's because we realized that by not having women on our research teams, we weren't addressing questions towards women. The classic one, not so much to do with computer science, is realizing that we've been testing medicine on men because women are difficult because we have hormones, so we can't do scientific experiments on them. And we get drugs to market that are designed for men and not women and actually have detrimental impact on women. The Horizon 2020 initiative is all about addressing that. We now need to be creative and figure out how that impacts us. It's less obvious in HPC. But have you ever looked at your training material and thought, is my training material designed for men? At the end of the day, we have all been taught material that has been developed by a male-dominated figure group. I do the same thing. I lecture probably material that was lectured to me. I've just modified it slightly. Do we actually need to consider that? The other big business implication here is that, as Richard mentioned, there's a huge skills gap in Europe right now. They're expecting that the number of tech jobs that need to be filled in the next decade in Europe is sufficiently high You cannot do it with just men. Even if every single man that was at all interested in technology jobs went into them, we will not fill them all. We therefore need our female workforce. Countries need a female workforce for GDP. It's pure mathematics, which is why businesses are now taking this into account as well. But we now have a problem. So we now know that improving diversity is important. So how do we go about it? First, we need to understand the problem. I'm going to go here to a survey of Russell Group universities in 2014 that was carried out by the Software Sustainability Institute. The survey found that 92% of the surveyed researchers use software for their research. My initial thought was, yay, everybody knows how important software is for research. It's not quite so exciting. Of these, 56% reported developing their own software. That's actually kind of cool from my point of view. I help people write software on a daily basis. Generally, I help people parallelize their software. So great, 56% of the UK research community need me. I have a job. But then we look at it broken down by gender. 70% of the men who use software also develop their own software. When we look at women, only 30% of the women who use software develop their own software. So for some reason in the UK, female researchers are far less likely than their male counterparts to be developing software. That is a huge hurdle to overcome. And it directly impacts HPC, because although many of the users of HPC will be using packages, will not necessarily be writing their own software, if they're not comfortable with using these technologies, not comfortable with even writing a script, some of the people were describing in this survey that developing software was writing a script to process data. A lot of the HPC community need to process data and write a script. If you're not comfortable with doing that, that's a hurdle to using these facilities and getting the best out of them. The survey also highlighted that there were gender differences when considering the preferred operating system. 26% of the survey's respondents reported using Linux. That's great. We're Linux-based. HPC is predominantly Linux. I think there's like one Microsoft Windows machine now in the top 500. On the other hand, when you look at the gender breakdown of those people that use Linux, it gets rather worrying. 86% of them were male. That leaves just 12% of the Linux users responding to the survey being women. So when our predominant operating system that they have to use in order to access our systems is Linux, that's another huge hurdle. Why? Why is that so different? One of my hypotheses about what's going on with Archer users that we've not quite managed to figure out yet is that many women are given access to Archer, but then potentially aren't using it. Is one of the reasons they're not using it because they're not familiar or comfortable with Linux. And I'm not judging women for that. That onus is on the rest of us, the people who are here. Why haven't we convinced women that this is not something difficult to do? We see a similar issue in training. The survey also found that women were less likely to have received training in software development. 69% of the male survey respondents had received training, but only 39% of the women. We see this replicated in our HPC training. So as I've already said, 21% of the Archer training attendees are women. But when we break it down into three categories of introductory, intermediate, and advanced courses, we find that the proportion of women attending the advanced courses drops off markedly. Attending the beginner courses, 30% of the attendees were female. That drops to just 11% on advanced courses. That fits in with what we were seeing with the PGAS conference, where we saw a marked drop to just 5% of attendees attending PGAS. PGAS may well be considered by many to be a specialist advanced topic in HPC. Clearly, in order to encourage more women to use HPC facilities, we need to encourage them to take up training. At the moment, I would posit the question that perhaps we are doing that in the wrong way. I don't have a perfect solution. I think if we did, we'd have solved this problem by now. There are enough people that care about it. But it's clearly a challenge that we have to face. One of the other biggest challenges we need to face is improving retention of the workforce. People are leaving technology jobs, men and women, across Europe at an alarming rate, especially when we have a skills gap to plug. We therefore need to recognize HPC as a valid career path. as one of the main reasons women have cited in a US study for leaving technology jobs has been work, lack of work career path, and salary. If we can't provide a recognized career path for men and women, we will lose them. These people are bright. You know, many of us in this room are working in universities. We could probably be earning a lot more in industry. We're here because we really care about it. If we're not going to recognize our careers as a career path, we have a problem. I think the recent recognition of the research software engineers in the UK as a valid career route is really important here. I know at the moment we've only got one of the funded research software engineers as a woman, but I think that is a route that has to massively change how we view that sort of contribution to our work. And yes, the final thing in terms of why this is happening, for those of you already thinking it, this problem does start at school. We need to improve the image of science and technology careers to girls. I don't know if any of you have ever done a Google image search for scientists. If you do it as an incognito search, it's really rather depressing. It's predominantly men in lab coats looking very geeky, the Albert Einstein image. Occasionally somebody sat over a dusty keyboard looking very tired in a dark room. That is not the image we need to portray if we want people to join technology jobs. We need to tell future people who want to work, men and women here, of how exciting it is to work in HPC. I always think to myself, I'm so lucky. I'm paid to go to work and play with the fastest supercomputers in the world. What could be better? That's not sufficient, though. That gives an image of somebody sat over a dusty keyboard. The other part that I wake up for each morning is I believe, maybe naively, that I go into work each day and I solve problems that make a little impact, that change the world just a little bit. I've been lucky enough in my career, starting out in physics, starting on molecular simulation of parts of the human body, understanding how HIV interacts with your body. I've worked on a project that's helped design nuclear fusion reactors and how wind turbines should be placed optimally in order to make the most of the resources available. I've got colleagues that work on climate models, predicting where Hurricane Sandy was going to land so that we evacuated New York City and saved thousands of lives. That was down to work done on HPC machines. That is the message we need to be getting across to school kids. It is not sufficient to say the fastest, shiniest supercomputer in the world, although that is kind of cool in my mind. So the final thing I want to talk about is how important role models are. So I should just keep an eye on the time. As we've already heard, Grace has been named after Grace Hopper. We have a duty here to recognize role models, and we also have a bit of a history in the UK of having policies of naming buildings after famous alumni, famous staff, famous Nobel laureates. The problem there is when the process is in place decades ago for those people to be that special person, excluded women. By having those policies in place, it means we can't recognize the women that we're around. Sometimes we need to take the brave step of throwing those policies out the door and thinking a little bit broader than that. It's simple things like whenever you mention Charles Babbage, try and think of Ada Lovelace as well. Most of those discoveries went hand in hand with the women, but they're pretty much invisible. Even if you try and do some research on this, women are very invisible. But we have a duty as a community to try and raise that profile. Role models are incredibly important, though. It's actually more important that you have a role model that's closer to who you are, that you can relate to. So for PhD students and undergraduates, that's early career people. For early career postdocs, that's seeing a professor that they can relate to. They're actually more powerful than having a machine named after Grace, as much as that is a fantastic step. So we need a workforce that women permeate the entire career path. We also need to recognize that holding up a role model where person X, amazing woman, overcame Y to do Z, as much as that is amazing, you're only going to be the first to doing something well once. Not all of us are going to stand up and break that barrier, and quite frankly, if we have something relevant to give to the scientific community, why should we have to overcome that barrier? There are many people who have something really profound to offer to science, but there are barriers in their way. I want to encourage all of us to bring our whole selves to work. Rather than conforming to the way we should behave at work, we should bring our whole selves to it. This is an initiative that's been taken up by Intel, for example, and they've found the retention of their staff has gone through the roof because staff are themselves. And that means they have role models they can relate to, be them men or women. Women don't need women and female role models, but what they need is somebody they can relate to. And that means being ourselves in the office. That means thinking that actually having a meeting in the pub after work is not necessarily the best thing to do. And actually that benefits men as well as women. Because guess what? Men actually want to go home and look after the kids as well. Well, maybe they don't. Who does? Am I allowed to say that in here? I think I'm very much over time. I just want to mention a couple of things that you can do. There is so much here I could talk to you about what we can all do. But there are 4 key ones. Recognize unconscious bias. Unconscious bias is currently a buzz phrase. You've probably all heard of it. It's sometimes, unfortunately, used as an excuse to hide behind, but it is really fundamentally important. We need to all recognize that we have implicit biases. It's nothing to be ashamed of. Every single human being on the planet has them. It's necessary to function, but we need to recognize they exist. Just saying, I'm not going to be biased is exactly the wrong thing to do. You can't just turn it off. It does not work like that. You need to recognize it exists and try and put measures in place to counteract it. The best thing you can do is have anonymous processes, such as what Supercomputing 2016 is doing, where they are going to have double-blind reviews. Secondly, consider your citation practices. A study of 4 prestigious philosophy journals over a 10-year period showed that 4% of citations of work from the previous decade were of female authors, even though 15% of the authors were women. These are prestigious journals. You wouldn't get published in that journal if you weren't good enough to be published. We need to all just be careful that we are citing everyone, not just the people we've met at conferences who are more likely to be men because women are less likely to travel. Thirdly, challenge conferences to address gender inequality. A very brave step I've seen many colleagues take is to use an invitation to be a keynote if all the keynotes are white men. Sorry to the white men in the audience, but you are part of the problem. I can say that because I'm married to a white man that I'm very proud of. But really, he's part of the problem too. And then finally, familiarize yourself with things like stereotype threat. It's really important that we recognize that when you are in a minority group or an underrepresented group, you may well exhibit a stereotype threat. We shouldn't hide that under the carpet. This is, for those of you who don't know, stereotype threat is a physiological phenomenon whereby a person's performance is affected by the perception that they belong to a stereotype. So if you think that you belong to a group of people who will underperform, and you are told that you belong to that group, you will perform worse. So we need to recognize that it exists. We need to talk about it. Again, not talking about it just makes it worse. Pretending it doesn't exist makes it worse. And most importantly, a token woman on a panel, or a token any underrepresented group on a panel, actually can make the situation worse. There's far more I could talk about here. But I do want to congratulate you, Grace, on having, 1, a fantastic machine, and 2, 22% of your users being women. I hope that hasn't been too depressing, but thank you very much for listening.